So today what I want to talk about is shapes of molecules. So here we have a Lewis structure for CCl4. When we're looking at this Lewis structure, we are primarily looking at the central atom. Here it is the central carbon atom, and how many pairs of electrons it has around it. We call these pairs of electrons electron repulsions because, of course, this electron pair which is negative and this electron pair which is negative and so on all repel each other as far apart as possible. So in reality, if we made a little model, it might look something like this. Okay, you can sort of see my toothpicks are approximately as far apart as they possibly can do, and no matter which way I turn it, if I made it correctly, it would look the same. We will play with our Mollymods when we get back to class. So if I were to draw on a piece of 2D paper, you'd see it like that. So I have my central carbon atom. This one and this one are on flat planes. So if you like, just one going up and one going to the side. One going up, one going to the side. One going back is this dotted line there, and one coming front, that's a little bit of a funny angle, but never mind, is that one there. And so they all have a bond angle of 109 degrees. They are as far apart as they possibly can be in 3D. That's the most important, 3D. That shape is what we call a tetrahedral shape. Okay. Now what we can do is also have another Lewis structure here. So this nitrogen atom, there's the Lewis structure, still has 4 electron repulsions around its central atom. So it would look very similar in terms of just the electron repulsions to what we had with the CCl4. However, one of them is not bonded to anything. So this pair of electrons right here is just not bonded to another atom. Okay, now these ones are still going downwards in a little pyramid shape. Okay, and so if we were to draw that on paper, a 3D structure on a 2D piece of paper, we would draw it like this. So one's just going out, one's coming towards us, and one's going behind. And we call it a trigonal pyramid because it is like a little pyramid shape. Okay, the bond angles are still the same as up here because we still have 4 regions of electron density around our central nitrogen atom. So we have 4 electron repulsions, or also known as 4 regions of electron density. Then we can come across to our something like water. This oxygen atom still has 4 regions of electron density around its central atom. However, only 2 of those are bonded to another atom. So we might draw it something like that, and we call it bent because, here we go. So I've taken one more out, and it is in a bent shape. And we don't need to do the forwards or backwards because you can see there they are just on a flat plane. So basically, if we have 4 regions of electron density or 4 electron repulsions around the central atom, it gives there is an angle between the bonds of 109 degrees. If all 4 of those bonds are bonded to another atom, then it's a tetrahedral shape. If only 3 are bonded to another atom, it is a trigonal pyramid shape. And if only 2 are bonded to another atom, it is a bent shape. Sometimes though we don't have 4 regions of electron density around the central atom, we might only have 3, like this one here. The main thing to notice here is that this double bond is 1 region of electron density. This is our other region, and there's our other region. So we've got 1, 2, 3 regions of electron density around our central carbon atom. So it might look like this shape here in reality. All right, this is a flat plane. In order to get just 3 things as far apart as possible, they take up a bond angle of 120 degrees. So on paper, we can just do nice straight lines. We don't need to do one coming forwards or one going backwards. This is a trigonal planar shape. So obviously trigonal comes from the fact that there's 3, planar, it's on a flat plane. All right, another one, sulfur dioxide. Sulfur, the central sulfur atom has 1, 2, 3 regions of electron density around its central sulfur atom, and only 2 of those are bonded. This one here is a lone pair. It is not bonded to another atom. So if I grab this and just take one out, then I have my lovely bent shape once again. But it is handy to note that this bent shape is based on a 120 degree bond angle, whereas this bent shape with water was based on a bond angle of 109 degrees. NZQA love to ask those types of questions. So once again, if there are 3 electron repulsions around the central atom, alternatively you could say 3 regions of electron density around the central carbon, like whatever atom, the bond angle is 120. If all 3 regions are bonded to another atom, it's a trigonal planar shape. If only 2 regions are bonded to another atom, it is a bent shape. And then of course we might come across something like carbon dioxide, which has 1, 2 regions around its central carbon atom. So we might draw it just like this. When you're drawing it, you can get rid of the, this is the drawing of the shape, by the way. You can get rid of the double bonds, okay? Just like up here, we didn't do that as a double bond, okay? It is a linear shape and it is 180, right? So that's this one here. Okay, these 2 regions of electron density are as far apart as possible. That makes the bond angle 180 degrees. I hope this video helps.